Hey guys, how's everything going? I'm JSer, who is not good at algorithm. Today, let's try to tackle this problem 1219 path with the maximum gold. In a gold mine grid with size m and n, each cell in this mine has an integer representing the amount of gold in that cell. 0 if it is empty. Okay. We return the maximum amount of gold you can collect under the conditions. Every time you are located in a cell, you will collect all that gold in that cell. Okay? From the position, you can walk to one step to the left or right, up or down. I mean, just move to the next cell, right? You cannot visit the same cell more than once. So there is no coming back. Never visit a cell with 0 gold. Okay, 0 cannot be touched. You can start and stop collecting gold from any position in the grid that has some gold. Yeah, sure. Well, I think I've done similar questions before. So actually, this is a typical backtracking problem. I mean, the idea is very simple. Just follow the requirement. There's nothing special. There's nothing as tricky. It just the way how we should do it. The idea is very simple because we can start collecting on any position. We will loop through all the possible position and start, right? So like if we start at 6 and then we can go up, of course we can where there's no position there, left no, right no, so we can only go to 8, right? And then 8 for after 8 we have still have 4 position directions we can go, but 6 is already picked, so we cannot go back to 6. And then we will try to go to 5 and then start from 5. We will check directions there, and 8 is occupied. And then after 5 is done, we will try to work on 9. But remember, when we work on 9, 5 should be released, right? It is now actually it could be reached if you can. So the problem becomes very simple. We use a recursion to just try to collect as much as we can, and if for each subroutes, if it is failed, we will release that cell. Once we collect a cell, we just froze that cell. So no more we can no means we cannot go back there anymore. For 0 cells, of course, we cannot touch them. Well, it is obviously that we need to maintain a two-dimensional flag array to check if the cell could be accessed or not, right? So at the beginning, 0 it cannot be touched, it cannot be accessed, and then we loop through all the possible gold cells, and then start the recursion from there, right? So it's very simple. Uh, I think this is something we did before, like n queens, something like that. Okay. So first we use from this video, I will start writing code that is much more, how to say, bottom top down. Means I will skip the detailed implementation and start using big larger blocks first, and then try to implement the details, so that in a real interview I will have enough time to explain what I'm doing. So I will use a flag to keep track of the availability of each cells. So it will be is available. Okay, this is to do. And then recursion, try to choose a cell. I would say walk. Wow, this is a typical walking, right? Imagine there's a little man, step on 6 and try to walk around. Index ij, and recursively walk around. And of course, when because we're going to check the maximum, right? So there is a variable called max, and we need to sum up current paths, right? So there is another variable called sum. Add to sum and update max, and then walk around. Don't forget to update availability. Walk around, and then update sum, update availability. And finally, when everything is done, and start on all the possible gold cell, return max, return. So, well, this is just a return max, okay? Now start on all possible cells. It will be okay for just loop through the grid. Oh wow, we could do. I think we could do better. It's for uh grid for each row I, row for each cell. IJ. Okay, now try to implement all the details. The first one is we need to initialize the flag, right? Well, this is very simple. I'll say grid map for each row, and it will map to another array, which is row map cell. If cell is 0, then false. Okay. I mean, so cell not equals to 0, right? Well, this variable is initialized, and then for walk, well, first we will add to sum, right? If I mean, we already let the little mouse step on this cell, so the sum will be plus. Oh, after we forgot the check the availability first, right? If it is able or not. If it is available, return. If it is not available. Okay, now it is available. Then we add to the sum and update the max. And then now we step on it. So we start walk around, but we need to update the availability first. Not walk around, walk around. Well, it's very simple. Walk. So when we walk to the next cell, the availability of current cell is already updated, so there's no problem. There are 4 directions. Now when all the subroutine is subroute subpath is already checked, then it means that there is no more need for this subroutine. So we need to release. We need to go to the next one, right? For from 8, after we check 5, 5 is done. Now we need to move 5 to 9. So 5 should be released, right? For each walk, step ij, if it is done, let's say we start on 5. Well, after 5 is traversed, we need to go to 9, right? So yeah, the sum should be updated. Well, wow, it's just a minus it back. It's okay. and then reset the availability. It's true. Return max. Oh, I think we're done. Let's try to run the code. Of course, there is a maximum call stack size exceeded. Ah, wow, we made a mistake that it is over. Where there might be possibly an overflow. But first, we need to check if it is still within the board or not. If smaller than 0 or bigger than greater than nth. Wow, let's just create some cache some cache some result variables. So this might cause error. Let's say the result because the length would be is bigger than 1, so it's okay. If I'll name the little man Jack. If Jack is beyond the board, over it is not in the board anymore, then there must be some problems. If it is over the board or it is not touchable, accessible, then we return. Well, this should work. Oh, still not right. What? Let's say console log walk a j. There's what? The test case is this, so 0 1 0 0 1, and then 0 2 0 3 is done 1 2. Oh my god, you should. Oh, I have never written the bug-free code at one pass. Submit. Yeah, we accepted and faster than 85%. Let's analyze the time and space complexity. Wow, it's actually it's actually like the worst case is that all the all the cells are all gold, and it's a full permutation, right? Worst case is full permutation of m and grid. So worst case m and this is the permutation, right? Yeah, but space. Well, first we use a two-dimensional array to store the availability, and you use a walk. The call stack of walk would be the worst and the cell count. So it's the same. Yeah. So that's all for this problem. Hope it helps. See you next time. Bye bye.